Discuss about supervised learning, and under that the technique that we are going to discuss about is a classification. So classification is a technique where our output variable is of categorical type. It could be of the binary or the multi-class. So binary means you have either yes or no, 0 or 1, and when we talk about multi-class, so it could be like either your mail is of spam, or it's your journal, or you can categorize it to personal, or maybe shopping or something else. So without wasting time into the theory, I'm moving into the Azure Learning Workspace. So this is my Azure machine learning workspace, and here you can see that one of my compute instances is running, and this compute instance is having some of my Python code and the data that which need to execute. Here you can see that there are different applications like Jupyter Lab, Jupyter, VS Code, RStudio Terminal. So you have option in which particular application you are quite comfortable to run with. With that, you can see here on the right and left hand side there are multiple options like notebook, designer, which we will be covering in further sessions. So let me first go into the notebooks. In notebooks you can see that there are multiple folders in which you can load any type of data, and you can directly load your CSV files as well, and you can load your Python code as well, which you can run from either here. Let me just show for the just for the testing purpose. So I have executed this. You can see that it has been executed, and if I execute this, and I'm just keeping the shift enter, so here you can see that these rows or the Python code is getting executed. However, that's not the right way, or the better way I would say, to execute the things or do the things. So in case you are quite familiar about Jupyter, so let me go to the Jupyter, which is inbuilt into your Azure machine learning. And with this you can see that's my tree node, and these are my folder structure. I have my classification modeling here, classification model here, which I'm going to run now, and I can show, that's the same program that we were just discussing. Let me first clear the output for you guys, and now I'm going to first load the libraries. So this is the Titanic data set, and that embarked those customers or the passengers which were actually on the voyage of Titanic from London to New York. However, they had very bad fate, and few of them got survived, but rest couldn't. And this data set depicts the different categories of those passengers, where they were placed in the Titanic, and what were their different age, gender, and which class they were in. That can actually help us in determine that what was the majority of the customer who got survived, and who didn't. So I won't go into the most of the Python code, but I will still try to tell that which are the ones that you can use. So I'm going to use info function, which will give me the information of which are the missing values of the columns, and is null function and summing up, which will give me the values which are actually missing. So here we can see there are three different columns which are missing: 177, 687, 2 for age, cabin, and embarked respectively. And the next step we are going to do is the validating data type, and that what type of operations we are going to do. And second is a missing value operation, which is more important. So for example, if we have the string variables, we cannot do the numeric operation, the missing value numeric operations on that. Similarly, for the numeric, we cannot do the string operations on that. So I will cover whatever is applicable for this section. So here what we are going to do, we are going to find out what are different data types we have, and with that we are going to find out different columns. Now what we have done is we are going to segregate these columns based on the object type, whether it's a float or it's a string one. So you can see I have defined two different arrays here. One is text and num, and num depicts what are my different numerical array. And then I'm going to do some missing value operations. So for example, this was my age column, and what I'm going to do is I had 177 different missing values in age column, which I'm going to replace with the mean value of age. I hope it is clear. So what I'm going to do is from 891 I had 177 missing values, and the rest 714, I guess, odd values, I'm going to take the mean or the average of it and going to replace it for the rest of the rows. Once I have done that, let me do it. It has done. Now once I have done, I have again used isNull function to find out whether any missing value is there, and you can see none. Now in the next step, what I am going to do is I am going to find out the most common values in the column of cabin embarked and going to replace it with a function, with a lambda function. Now you can see here what I have done is I have used here a value counts function. So let me let me show you how it works. So suppose I do this cabin and embarked, and sorry about that. I should not be using some then. Yeah, so if you see this, so I have S, C and Q, three different values, and S is the maximum one. So I'm going to take the index as S and going to replace all those values with S. Similarly, I'm going to do the same activity for cabin. So I'm removing this step here, and that I just showed for the demonstration purpose. So here these step has been included, and here you can see what I have done is I have created two different columns, cabin and embarked, and those cabin one and embarked one, and I'm going to apply those filtering, or I would say operations onto those columns. And with the embarked one, if I see, there are none missing values. And now in cabin and embarked, it is still there because we have performed our operation on cabin one and embarked. So here you can see it's all done. Now what we are going to do, we are going to apply those value into cabin and embarked, and here you can see it's all done. Now for the testing purpose we did that, and now we can easily or simply drop those columns. So you can see that with this we are actually performing all the Python operations as well, so that you can get flavor of it, that what are the different steps you need to do depending on the requisite that you have. All right, and then you can see, okay, so cabin one embarked has been dropped. So now we are going to draw some plot diagram, and with this box plot you can see that there are so many outliers. So we need to find out how many outliers we have and how to remove those. So what we are going to do, we are going to run some statistics, and here we are going to perform to find out the percentile, and that's IQ, QR1 and QR3, so interquartile and outer quartile, that we are going to find out these ranges. And with this we are going to find out our maxima minima. And now we can see what we are doing is, if any of the value is inside minima and maxima, those values we are going to keep it, otherwise we are going to call it them as outlier. So what we have done is we have defined a range based on our quartile range, and with this we are finding out which are the values are actually outliers and which are not. So whatever minimum values, if our value is the fair, for fair, if it is greater than our minima and if it is less than maxima, then we are going to take it yes, otherwise no. So let me execute that. So what we are doing here is we are keeping it a column here out, we have created a new one, and with this we are finding out those values, and we found that yes, there are 116 which are outlier and we can remove this. So we have removed those ones, and now we are just rechecking it. And with this, next step what we are doing is we are performing the one hot encoding. I hope you are quite familiar about it. So we have embarkment column which has the value CQS, and on this the machine learning cannot be performed, so that's why we are going to perform this 100 encoding. So that will transform our column into 100 001 010. Let me show you. So once I perform this operation, so here you can see that these three different column has been created, CQS, and with the value, if it is S, so S has 1, if it is C, C has 1, and similarly if it would be Q, so Q will be 1, so rest of value is 0. So in this way we can easily perform our machine learning operations, and that's the actual way of doing it. Going down now, I mean that's the same operation that we did. And similarly for male and female, now we need to transform it to 0 and 1, and these are the steps with which we are going to do. And here you can see we have created a new column X, and that is for 1 and 0, one for male and for female 0. and now we are going to drop multiple columns which are not required for us, and we are going to only use those columns which are required in the machine learning operation. Now we need to identify which are our dependent or the independent variable, or you can say your input feature or output features. So now what that we have already done, so we know that this is the column survived on which we are going to do our predictions. So this will be our y column, and rest all these columns will be x. So here we are going to perform some eye locking, and with this we can actually segregate our x and y columns from this particular columns data frame. So I have just done it, and with this if I do print, so I can see that these are different column we have, and if I say y, then it will be only survived, that I would be getting survived here. So let me remove it for the sake. And now what we are going to do is our next step, we are going to split our data into training and testing. With that we can actually we are going to train our model and later going to test it. So we are going to split it into our 80-20 ratio. So our test size is 20, so that means our training is 80%, and random state is you can give any number. I mean 1 2 3 if we give, that's more better and suitable. So with this I'm going to execute this. Now if I execute my x train data, so I can see that there are 712 rows. So out of 891 we can say it has been closely coming to 80% to 712. And similarly if I go for y train, it is close to 712, so that is your 80%. Now if I take my y test, so okay, so that is 179, so that is 179 and 712. So let me go back. So I have done that again. Okay, so now we are going to do our machine learning modeling, and now in this particular example we have different models that we have used to find out that what's our different metrics that we are going to generate. I won't go into much detail of those, but still for the sake I'm going to show that how we are going to different models, use different models, and how expediently we can perform those. So first one is a RFC, random class forest classifier, and with this we are creating the object. With this we are fitting it, or I would say training it. Once my model has been trained, I am going to use my trained model to predict for my x test. Remember, x test was the one that we took it for 20% ratio, and that's my input variables for the testing, and y test will be my output. So here I'm taking the value into y prediction, so I'm going to predict based on the prediction that I have done before from x train and y train, and with the x test one. So let me run this. Done. So now I'm going to generate some of the metrics. So for classification we have many metrics like accuracy, confusion matrix, precision, recall, even F1 score, recall score. So I'm not sure how many I have used here, but still for the sake of purpose let me go through one by one. Accuracy score, I have run it, and now accuracy score we are going to predict on what was the actual value versus what our model has predicted. So here you can see our y pred model has predicted some of the values, but if for y test we already has those values, so we are going to compare it. So what was the accuracy? So we can see here 82% accuracy. Our model, the RFC model, has generated 82% of accuracy. And then we have confusion matrix, you know, true, false, and that TP, TN, FF, FN, FP. So those false positive, false negative, true negative, those values. So these are the values that you can see. And then we have precision score to find out that what's our precision of the model, so 73.91. Then we have recall, and then recall values of 78.78. And this is the feature importance. So this feature importance, what it does is that it actually shows that to get this value 82%, what were the different features which are more important, or what was the percentage of the feature which has actually contributed in this accuracy. So if I run this, so we can see here, so they were like features were like 80.86, 0.2789. Now we need to correlate with our columns, that which were our columns, and then giving the values. So if we see here with this code, so we can see fairly the fair and age and the sex ratio has contributed maximum for our accuracy and in predicting the whether whether the passenger might have survived or not. Going back, now we have another more examples. We can use logistic regression. With logistic regression, if I see the accuracy, it's coming 80, so still it is less than RFC. And then the next model I'm using is my discriminator. Here it is giving me 81, which is again quite less, and I can see the accuracy score as well, 81, which is again not so good for quadratic discrimination and linear discrimination. Then we have KNN classifier. With KNN classifier, I'm getting 65%, which is quite bad. The next one I can use is decision tree model. With decision tree model is again 79, so which is again not so great in comparison to RFC. From decision tree classifier, we have seen that. Now we have AdaBoost classifier. With this, we can see we are getting 83%, which is quite high. So that means AdaBoost classifier can do wonders if we use this for our most of the classification. And then the last, not the least, is the gradient boosting, which is again showing 83.24, quite close to our AdaBoost. So this is the way how we can actually perform our modeling and predict the variables based on our inputs. So I hope you like the lecture, and in the next one we are going to discuss about regression. Thank you guys.